Hello everybody, this is the notes for geometry section 3.2. In the first section of chapter 3 we talked about just the positioning of the angles and how they're related to each other, the corresponding angles, where they were, alternate interior angles, alternate exterior angles, the consecutive interior angles. We just talked about here's two lines and a transversal, these angles, they're corresponding, these angles, alternate interior angles. So what we're doing in this section is now making those two lines parallel and still having that transversal go in there. So what I want you to do is take a look at this picture here. What I have is two parallel lines. No matter where I move the line, they're staying parallel to each other. All right, what we have is line DE, this one I'm moving out. That is the transversal. So I've measured the four main angles at each of the intersections of the transversal and the two parallel lines. So I want you to just pay attention to the corresponding angles. All right, where this cursor is here, the 64, and then where the cursor is now at that 64. Those are the corresponding angles. So pay attention to those measurements as I just move these pictures around. Notice how they're always staying equal to each other. Okay, any of the other pairs of corresponding angles, they're staying equal. So what we can say is when you have parallel lines cut by a transversal, corresponding angles are going to be equal. All right, so now let's look at the alternate interior angles. So where the cursor is here, this 109, its alternate interior angle would be this, where the cursor is here, that 109. Notice how those two angles are staying the same. So is the other pair of alternate interior angles. It doesn't matter how I move this picture around. Those alternate interior angles, they're staying congruent to each other. Same thing's happening with your alternate exterior angles. This 71.2 there, that's 71.2 there. Those are alternate exterior angles. They're staying congruent, no matter where the parallel lines are, no matter where the transversal is. Doesn't matter. Okay, if I turn the transversal, has no bearing on it. Alternate interior angles are staying the same, corresponding angles are staying the same. Alternate exterior angles are staying the same. The last pair is the consecutive interior angles. What we're looking at is this 109.9 and the 70.1. All right, if you add those two numbers up, that's 180 degrees. Same thing with the other pair of consecutive interior angles. It doesn't matter where I move them. Now they're looking at 110.36 and 69.64. You add those up, that's 180. If I move these, it's kind of hard to see them now, 60.13, 119.87, that's still supplementary. So when you have parallel lines cut by a transversal, consecutive interior angles are supplementary. All right, so if you want to mess with that drawing, here's a link to it in this baby blue color. Feel free to play with it. I want you to hit pause, copy these things down. We'll fill in the blanks in a second here. Okay, so corresponding angles postulate, alternate interior angles postulate, all these four different things, they all start exactly the same way. If two parallel lines are cut by a transversal, then. So, for each one of these things, going back to that drawing I was messing with, you had two parallel lines cut by a transversal. The corresponding angles, they were congruent to each other. The alternate, looking at the second theorem here, alternate interior angles, if two parallel lines are cut by a transversal, the alternate interior angles, they were congruent to each other. Alternate exterior angles, parallel lines cut by a transversal, alternate exterior angles, they are congruent to each other. The only one that's different here is the consecutive interior angles. Again, same start. If two parallel lines are cut by a transversal, then the consecutive interior angles are supplementary. Okay. So, as some examples, we'll do a couple of these. Let's look at number 17, this top one on the left. We have our parallel lines. What you're looking at in the picture is those arrows right there in the middle of the lines. That's telling us those two lines are parallel to each other. So when we look at the 80-degree angle and this x plus 15 angle right there, those are alternate interior angles. Okay, they're in between the two parallel lines. They're on different sides of the transversal. So we have parallel lines cut by a transversal. We're dealing with alternate interior angles. They are congruent to each other. So that x plus 15 angle, it is the same thing as the 80-degree angle. And so to solve for x, we would just subtract 15. X equals 65. All right, looking at number 18. What we have here, we got our parallel lines. We have our transversal. These two angles, they're on the interior of the parallel lines, and they are on the same side of the transversal. So these are consecutive interior angles. These are supplementary. So we're going to add them up to set them equal to 180. And then the algebra to solve it. Subtract your 68. So that puts us at a 112 equals 2x. Divide both sides by 2, we get 56. Okay? Looking at number 19, I'll just set it up, but we have parallel lines, we have a transversal, our two angles are outside those parallel lines and on different sides of the transversal. So that's alternate exterior. Alternate exterior angles are equal to each other. So we set those equal. Looking at this last picture on the bottom left side of the screen, parallel lines, we have a transversal. These two angles are corresponding, so they're equal. And we would just divide by 3 to solve for x. All right, that, I believe, we can try these in class. So that is it for the notes. Have a great night, and I will see you in class tomorrow.